Hi everyone. In my previous video, I have discussed about Databricks incremental data loading using copy into feature. Today, I will be discussing about incremental data loading using Autoloader. Let's get started. Let us first consider the scenario. What used to happen to the incremental data loading without Autoloader? On the left side, you observe here the folder where the files are expected to be landed. And now Databricks will be using Spark structured streaming engine to read the data from this folder. As you see here, when the structured streaming engine is starting to look at the files in this folder, let us consider that's happening at t equals to 0 time. So it's going to take a look at the list of the files that are available, and then it will start reading them. And after reading, of course, the related transformation of the data happens using the Spark engine, as well as Spark will be maintaining the list of the files that are already ingested into the Spark platform. But what's the problem here? The problem here is that when next time few more files are going to arrive in this folder, Spark has to poll continuously for the new files that are arriving in this folder, and it has to ingest them into the Spark platform. For that, each time it is going to poll for the new files at the folder, it has to compare against what other files it has already ingested, right? After comparing the list of the files it is maintaining at its end and the list of the files that are present in the folder, okay, the difference it's going to take, and whichever newly arrived files are there, those files should be ingested going forward. But this is not the scalable solution. Okay, what if we have per hour maybe hundreds of thousands of files being ingested into this folder, and performing this kind of directory listing based solution is not scalable. Fine, we face the performance issues. This is one thing. The second thing is that let us assume initially maybe these two files add this kind of schema, just two columns, customer ID of int type, and maybe write the first name of the customer to be of string type. Fine. So initially when the files were loaded, it's well and good, and the columns were two. But what if the newly arrived file, for example, customer 3, is coming with additional column of maybe the last name of the customer. So our Spark structured streaming solution, which is working here for the incremental data loading, fails at handling this kind of schema changes happening from the source, right? So this is where, if we just go with the Spark structured streaming, we have to take care of these schema changes manually, which is again not advised to follow in the production. Fine. So that's where we have the autoloader feature being offered by the Databricks. So it is the feature built on top of the Spark structured streaming, and whatever earlier the developers used to do manually, uh, it's about listing the files, and are maybe about schema changes, are about maybe getting notification whenever the files were landed onto the folder and all. So all that is now provided out of the box, and this solution is provided out of the box for the cloud storage based sources. Okay, autoloader is the feature that loads data continuously and efficiently from cloud storage as the new data is going to arrive. So it has to be one of these. It has to be Azure Data Lake storage, or it has to be Google Cloud Storage, or Amazon S3 buckets. Fine. Majorly, these are the cloud storage options that we have. And over these, okay, storage locations, Autoloader supports for ingestion of JSON data, CSV data, Parquet, Arrow, binary, and text data. So how does it work? Let us see, maybe, but before knowing its mechanism, let us have a look at the key features of the uh, Databricks Autoloader. One is a simplified data ingestion. Since the solution gives lot of features out of the box, it is scalable. It handles schema inference and evolution. Fine. It gives us optimized solution. That way, we have cost effective solution also here, and it helps us in near real time data processing. And the solution is also fault tolerant. Let us look at how the things are going to work with Autoloader. As you see in this diagram, the source for the autoloader is the cloud storage. Okay, as and when the files are, you know, landed onto this cloud storage, the autoloader should be able to pick them up and ingest it into the Databricks platform. So we have here two mechanisms. One is the directory listing mode. The other one is the file notification mode. First, let us look at the directory listing mode. The directory listing mode is nothing but the one we looked at earlier. Fine. Uh, with autoloader also, still we have the option of directory listing, and we can go about using it with the cloud storage being the source of the data. And it's going to be efficient as autoloader has optimized things at the framework level, and as it is the cloud storage, right, compared to our Spark structured streaming solution, this is going to be more efficient, and we can use it when the data is not of that scale, right? For example, maybe hundreds of thousands of files are there, then we can opt for this solution. Fine. Here, the autoloader is going to maintain the list of the files that it has ingested and all, using the database called RocksDB. Fine. So things go on that way, and the Spark structure streaming can ingest the data into the data um, Databricks platform. That is nothing but the Delta Lake tables and all. Fine. So this is one option we have, but this is not scalable when we expect huge number of files to be landing into the cloud storage. Maybe hundreds of thousands, the millions of files are coming, and at that time, so performance wise, directory listing mode is not going to yield best result. So that's why we have file notification mode, uh, making use of the event grid kind of things in the Azure cloud and all. As soon as the file is loaded onto the cloud storage, the event is triggered, and the file that was loaded into the cloud storage, right, it's being put into the message queue, and its details are again listed onto the RocksDB and all. So as immediately as the file is arrived here, the Spark is going to that way, right, pull those files from the queue, and it's going to ingest it into the Databricks platform, right? So this is how we have two options here. And going ahead, I will be demonstrating in this video uh, using the directory listing mode. In my upcoming video, I will be demonstrating about how do we ingest data using autoloader using the file notification mode. Before I move on to the hands-on part, let us look at few of the important information about the autoloader. This is what I have discussed, and directory listing mode is the default one. This is the one I will be demonstrating in few minutes. As I talked about in the key features of the autoloader is capable of inferring the schema. So okay, and it can also deal with the schema evolution. But for this to happen, for the autoloader, you should be giving certain location where it can track the schema related information for our data source. So that's what I'm mentioning here. Schema location is required for the schema evolution to work. And Databricks gives us different schema evolution modes, right? As I discussed in the example. So first two files may be having two columns, but the third file that is ingested is having three columns. Then autoloader has to deal with it. So for that, we have these four different kinds of the evolution modes. One being the add new columns. Second is the rescue data column. fail on new columns, and none. Among this, default is the add new columns. So initially, two columns were there, and later, if the three columns are coming, this new column has to be accommodated in our target table, right? So for that, we have this new add new columns option, and this is the default mode. It automatically adds new columns to the schema as they appear in the data, and it is the simplest mode for handling the schema changes. So we will explore all of these modes in a while. Next, we have something called rescue data column. It's going to capture the data that doesn't fit to the current schema. For example, this was the initial schema, but later the schema evolved to be of three columns. So this additional column will be kept in one specialized kind of column called as rescue data column. Okay, hold on for a while. Maybe the things are a little confusing here, but as you see the demo, you will get more clarification. Then we have one more option of fail on new columns. Okay, in this case, right, as you're saying, so as soon as it is detecting the new schema, the entire pipeline is going to fail, right? So that is, so here we are enforcing strict schema. And next we have something called none. It doesn't support schema at all, right? So if at all new columns are coming also, they are very silently suppressed, right? They are dropped. So new columns are ignored. So these are the different modes we have. And how do we go about setting up the autoloader then? As I told you, autoloader is built on top of the Spark structured streaming. So it's about reading the continuously ingested data. So it has to be spark.read stream. But then after that, we have to specify that we would like to do this data ingestion using the autoloader feature. So we do so by mentioning this format cloud files. So this is very important. So cloud files. For our autoloader, the data source is nothing but cloud storage. So by that, maybe right, you can remember the format has to be cloud files for the autoloader. Next up, over the cloud storage, what kind of files you are expecting to be ingested. So that's where you have to set it as cloud files dot format. It can be JSON, it can be CSV. I think 5 to 6 types are supported, so it can be one of those. Next, I was mentioning for dealing with the schema changes, we should be providing location for the autoloader where it can track the schema changes, right? So that's what cloud files dot schema location. So all these properties of the autoloader should be set properly using the option method. And finally, you are going to give here the folder where you are expecting the files to be loaded, the files to be ingested. Fine. So after that, the data frame is there, and whatever, right, we would like to do, we can perform operations on it. And once all the transformations are done, you can go about writing that data to the maybe right destination order. Here I'm just considering that we are picking the data as it is, and we are going to save it as a delta table. So that's where data frame dot write stream dot format delta. Though it's always good practice to mention the format. Fine. So df dot write stream dot format delta, and checkpointing location should also be provided for our streaming workloads. And this is output mode append because we are trying to ingest data here. And while writing the data to the target table also, target table should be accepting the schema changes. So that's where we mention merge schema to be true. Fine. So, and finally, we are saying all of this data frame should be stored as a table. Two table we are mentioning, and this is the name of the table. So after that, you should be able to see this table in your catalog. And uh, okay, as and when the new files are arriving, the data in this table should be growing, right? So this is a concept. And here, if you got little confused with respect to schema, uh, evolution mode, and the merge schema. So I've just listed over here. Schema evolution mode is something that we apply at the autoloader end, right? That is while reading the data. So it happens with respect to the data sources. Merge schema is something we are applying for the delta write operations, right? df dot write stream. So at that time, so it is a write time kind of the feature that we have to set. So schema evolution mode controls whether autoloader has to update the schema, and this merge schema controls whether write operation has to update the schema, right? And the typical values are going to be add new columns. Okay, this is a default one. And okay, so mud schema, typically we set it to be true. Fine. So default, it's coming to be none here. Actually, this is wrong. Okay. The default value of schema evolution mode is add new columns, and default value for the merge schema is false. Fine. So this is the case. Uh, I will be continuing the hands-on part in the next video. Please stay tuned. Thank you.